So, continue. Going to continue looking at our trig identities and how they can be used. We saw yesterday that we can use them to simplify expressions involving trigonometric functions. One of the other uses of using these trig identities is we can determine the exact value of the sine, cos, or tan, or one of the reciprocal ratios of an angle that's not on the unit circle. I mentioned this yesterday, that it could potentially lead to that. And it does. You want to find the exact value for the sine of pi on 12. Pi on 12 is not on the unit circle. Right? Our first angle on the unit circle after 0 is pi on 6. Pi on 12 is half of that, not on there. So we can do this using sum and difference identities. In this case here, we would have to use a difference identity for sine. And the key is you have to find two angles that will subtract to get pi on 12, and both of those angles must be on the unit circle. So again, we are going to use the difference identity for sine, which is on the formula sheet. The sine of a minus b equals the sine of a times the cosine of b minus the cosine of a times the sine of b. That is on the formula sheet, right? So you don't have to memorize it. It's there for you. But again, we need to find two angles that subtract to get pi on 12, and both of those angles must be on the unit circle. So not any two angles would work. For example, and you don't have to write this part down, but let's say we tried to use 5 pi on 12 minus 4 pi on 12. So they do subtract to get pi on 12. However, that first angle is not on the unit circle. 4 pi on 12 is, though, because that reduces to pi on 3. If you take 4 pi on 12 and you divide top and bottom by 4, you will get pi on 3. So that angle is on the unit circle, but 5 pi on 12 is not. So your key is you have to find two angles that not only subtract to get 1 pi on 12, but also both of those angles must be on the unit circle. And so the ones that would work here would be 4 pi on 12 take away 3 pi on 12. Because when you reduce both of those angles, you do get angles that are on the unit circle. So this will be the sine of pi on 3 take away pi on 4. If you reduce 4 pi on 12 by dividing top and bottom by 4, you'll get pi on 3. And if you reduce 3 pi on 12 by dividing top and bottom by 3, you'll get pi on 4. These two angles are on the unit circle. So to do this then, we refer to the difference identity above, where A is pi on 3 and B is pi on 4. We're going to get the sine of pi on 3 times the cosine of pi on 4 minus the cosine of pi on 3 times the sine of pi on 4. And now we can work this out using, once again, our unit circle. So to get those values, we have pi on 4 and pi on 3. So at pi on 4, the coordinates are both root 2 over 2. And at pi on 3, it's 1/2 comma root 3 over 2. Remember, you can get that using that hand trick, right? So pi on 4, that's your middle finger. It's the root of this many fingers over 2, the root of this many fingers over 2. Root 2 over 2, root 2 over 2. Okay. At pi on 6, that's the finger next to your thumb, root of 1, which is 1 over 2, comma, root of 3 over 2. So that's where those values come from. And so now we can plug them in. The sine of pi on 3, remember sine is the y value. That's root 3 over 2 at pi on 3. times the cosine of pi on 4, which is root 2 over 2, minus the cosine of pi on 3 is a half, times the sine of pi on 4, root 2 over 2. So this gives us root 6 over 4 minus root 2 over 4. Because they both have a denominator of 4, you can combine them into one expression. There's your answer. That is the exact value of the sine of pi on 12 radians. That's an exact value. Right? It's not a decimal that you would have to round. And like we've seen so many times, we can use our calculator to check our answer. In this case, we have to be in radian mode. If you take the sine of pi on 12, your calculator will give it to you as a decimal, which is not an exact value. But we can take the exact answer that we got, put that into our calculator, we should get the same decimal that we just got for the sine of pi on 12. So the answer we got was the root of 6 minus the root of 2. So that's all together in the numerator. That's all divided by 4. Get exactly the same decimal. So that shows that the answer we got is correct. But we got it as an exact value. Your calculator will not give it to you as an exact value. As we've seen, we can use our calculator to check our answer, but it doesn't give us the answer as an exact value. You need to use the difference identity for sine in this case to do that. All right, so there's another use of our sum and difference identities. Question B, we want to find the exact value of the tangent of 105 degrees. 105 is not on the unit circle. Sure, we can use our calculator in degree mode to find out what the tan of 105 is, but it'll be an approximation because it'll be a decimal that we have to round. Negative 3.73, etc. To find the exact value, which we're asked to do, again, we'll have to use our sum and difference angles, our identities, and we need to find two angles that either add or subtract to get 105, and both of those angles must be on the unit circle. So in some cases, there may be more than one way to do this, but in this case, one of those ways would be taking the tangent of 60 plus 45. 60 plus 45 equals 105, and 60 and 45 are both on the unit circle, so they will work. Okay? They will work. And there might be other angles that will work, okay, possibly. You just have to find one set of angles that would work, okay? One set of angles that would work. I think 120 minus 45 would also work. No, that's not true. 120 minus 45 doesn't work. There might be only one set of angles that'll work for this one, but in some cases, there are more than one set. So for this one, we have to use the sum identity for tangent, which is tangent of A plus the tangent of B. And again, these are on your formula sheet. You don't have to memorize them. All over 1 minus tan A times tan B. That is the sum identity for tangent that you would find on your formula sheet. So we need the tangent values at 60, which is the same as pi on 3 radians, as well as 45, which is the same as pi on 4 radians. And so we worked these out before. At pi on 3, the tangent was root 3, and at pi on 4, you're dividing sine by cos, remember, in each case. At pi on 4, the sine and cos values are the same, so when you divide them, you'll get 1. So the tan of 60 is root 3, the tan of 45 is 1. So this will be root 3 plus 1 all over 1 minus root 3 times 1, which gives us root 3 plus 1 over 1 minus root 3. And you might remember back in 20-1, you did learn about working with expressions that had radical denominators, that you shouldn't leave your answer with a radical denominator. We rationalized the denominator, and there were two different types that we looked at. Okay, the first type was if the denominator was just a single term. And we rationalize that by multiplying top and bottom by whatever the radical part of the denominator was. In this case, though, the denominator is a binomial, 1 minus root 3. So in those cases, to rationalize the denominator, we multiplied top and bottom by the conjugate of the denominator. When you factor difference of squares, you get conjugates, same two terms, opposite sign in between. So we need to multiply bottom and top by the conjugate of 1 minus root 3, which would be 1 plus root 3. So now when we do that on top, it's binomial times binomial. We can FOIL those out. Root 3 times 1 is root 3. The outer products, root 3 times root 3 is root 9, which is 3. The inner products, 1 times 1 is 1. And the last terms multiplied together, 1 times root 3 is root 3. On the bottom, again, we'll FOIL those out. The front terms multiplied together, 1 times 1 is 1. The outer products are positive root 3, but the inner products will give you negative root 3. They cancel. This is why we multiply by the conjugate. Those outer and inner products will always cancel. And the last terms, a negative times a positive is a negative. Root 3 times root 3 is root 9, which is 3. So when we simplify this, we're going to get 4 plus 2 root 3 on top. And on the bottom, the root 3's cancel. 1 take away 3 is negative 2. And now we can divide every term by negative 2 because on top you have two terms. They're both divisible by 2 and also negative 2. And the reason we divide by negative 2 is we would get rid of the denominator completely. When you divide all three terms by negative 2, the denominator just becomes 1. But on top, 4 divided by negative 2 is negative 2. 2 root 3 divided by negative 2 is negative 1 root 3. So there would be the exact value of the tangent of 105 degrees. When we did it on our calculator, we got it as a irrational number, a non-repeating, non-terminating decimal, which is not exact. But now we see what the exact answer is, and when we plug that in, we should get the same decimal that we did above. And we do. So that confirms that our answer is correct. Only we now have the exact value of the tangent of 105. Okay? So, again, we're going to use sum and difference identities to find the exact value. The first one, the cosine of 165. Well, 165 degrees is not on the unit circle. But we can use the sum identity for cosine because 120 plus 45 does equal 165, and they are both on the unit circle. 120 degrees has a reference angle of 60. But now we're using the sum identity for cosine, which is on the formula sheet. It'll be cos 120 cos 45 minus sine 120 sine 45. So that is the sum identity for cosine that's on the formula sheet. Yeah, I did. Yeah, I can give you one after. Okay? Thank you. So, cosine of 120, that has a reference angle of 60 degrees. And it's in the second quadrant, which is our S quadrant when we use the cast rule. So the cosine is negative there. The cosine of positive 60 is a half. So the cosine of 120, that's again, has a reference angle of 60 degrees in the second quadrant, will be negative a half. The cosine of 45 is root 2 over 2. Minus. The sine of 120, again, is in the second quadrant, but there the sign is positive. That's the S quadrant when we use our cast rule. It has a reference angle of 60 degrees. The sine of 60 is root 3 over 2. So the sine of 120 will also be root 3 over 2. Times the sine of 45, which is root 2 over 2. When you multiply these out, you're going to get negative root 2 over 4 minus root 6 over 4. Again, we've got a common denominator there. So we can combine those two into one expression. And there's our answer. That would be the exact value of the cosine of 165, which we can check on our calculator. Again, we need to be in degree mode, which we are. The cosine of 165 is that decimal. So if we check the answer we got, the negative root of 2, whoops, try that again, negative root of 2 minus the root of 6 all over 4, same decimal. So it checks. We've just shown that the answer we got is correct, but we got our answer as an exact value, which what we were asked to do. Okay. Question B, we want to find the exact value of the tangent of 11 pi on 12. So we need to find two angles that either add or subtract together to get 11 pi on 12. And in this case, I think there are a couple different options. If you go 15 pi on 12 minus 4 pi on 12, I think that'll work. Just to confirm that, if we reduce 15 pi on 12 by dividing top and bottom by 3, you'll get 5 pi on 4, which is on the unit circle. And 4 pi on 12, if you divide top and bottom by 4, you'll get pi on 3. So that would work using a difference identity. But we could also do this using a sum identity. I think 8 pi on 12 and 3 pi on 12. Should also work, because 8 pi on 12, if you divide top and bottom by 4, you'll get 2 pi over 3, plus 3 pi on 12, again, divide top and bottom by 3, you'll get pi on 4. So both of these would work. It doesn't matter which one you use, you would get the same answer. Doesn't matter. Let's use the second one. The tan of 2 pi on 3 plus pi on 4. So again, this would be using the sum identity for tangent, which is on the formula sheet. It's the tan of A plus the tan of B all over 1 minus tan of A times tan of B. And you could also use 9 pi on 12 and 2 pi on 12 as well. That would work. Yeah. 5 pi on 12 doesn't reduce, so no, you can't. But 9 pi on 12 and 2 pi on 12 would reduce. So you could also use those. It doesn't matter. So 2 pi on 3. So that would again put us in the second quadrant. It would have the reference angle the same as pi on 3, where at pi on 3 the tangent is root 3, but in the second quadrant tangent is negative, so it'll be negative root 3 plus tan of pi on 4 is 1 all over 1 minus negative root 3 times 1. So this gives us negative root 3 plus 1, or 1 minus root 3, all over 1 plus root 3. Because the negative becomes a positive, and root 3 times 1 is root 3. But we shouldn't leave our answer like that, because we have a radical in the denominator. So to rationalize the denominator, you need to multiply top and bottom by the conjugate of the denominator, which will be 1 minus root 3. So on top, when we FOIL those out, the front products will be 1. Outer products will be minus root 3, which will be what the inner products are. So those don't cancel because they have the same sign. And the last terms, a negative times a negative is a positive. Root 3 times root 3 is 3. On the bottom, in this case, the outer and inner terms will cancel because we're multiplying by conjugates. Front terms multiplied together, 1 times 1 is 1. The outer products is negative root 3. The inner product is positive root 3. There they go. They cancel. And the last, a positive times a negative is a negative. Root 3 times root 3 is 3. So this gives us 1 plus 3, which is 4, minus 2 root 3, all over negative 2. The root 3's cancel on the bottom, so you're left with 1 minus 3. And again, I will divide everything by negative 2, which will make this minus 2 root 3. When I divide it by negative 2, it'll be positive root 3, and the 4 divided by negative 2 is minus 2. So there's our answer. That is the exact value for the tangent of 11 pi on 12, which we can check in our calculator. We just have to make sure that we are in radian mode. The tangent of 11 pi on 12 is that decimal. If we take the answer we got, which is the root of 3, take away 2, exactly the same decimal. So our answer is confirmed. But we found it as an exact value instead of the calculator, which gives us an answer as an irrational number, so it has to be rounded off, and therefore it's now an approximation. So you're going to work on those questions, and this one you are going to hand in. This one is due for marks. Remember, Friday is when you're going to have your quiz on chapter 6. Sorry, I apologize. I'm looking at block 3. So it'll be next week sometime when you have your quiz, and we'll be finishing off this unit. And so probably next week will be your unit exam as well. But I'll figure that out and let you know tomorrow for sure when those dates are. Okay. We're going to go through the chapter 4 quiz right now.